Okay, 1.5, graphing parabolas factored form. What if the quadratic equation is in factored form? So let y equals x plus 2 times x minus 4. It's in factored form because we have two factors here, and if we multiply together, you see no plus or minuses between those parentheses. So that's why we know it's factored. How do you know the graph will be a parabola? So what you want to look at is if you were to FOIL this and you did x times x, then you would get x squared. So FOILing gives us x squared. Okay. Does the parabola over up or down? Well, if you look, we have, and we multiply it out, we got a x squared here. X squared is positive, so it opens up because x squared is positive. Okay, so what are the zeros? The x-intercepts of the function. So when we're in factored form, if we set y equals 0, then we get to set those two factors to 0 and solve for x, and that'll give us our x-intercepts. So if we say 0 equals, set y to 0, x plus 2 times x minus 4. And then now I'm just going to set what makes those 0. So if I set x plus 2 equals 0, let me write this in different colors so you can see it better. You set x plus 2 equals 0, x minus 4 equals 0. Well, that just gives us an x equals negative 4. Excuse me, x equals a negative 2. And x equals a positive 4. So again, x equals negative 2. X equals positive 4, and those are x-intercepts. We're going to write them as zeros. So negative 2, comma 0, and 4, comma 0. Okay, those are our 2 points. There's your zeros. Now, next question. Do you have enough information above to sketch the graph? Well, what do we have above? We just have the 2 points, so let's go ahead and plot them. So here's one at negative 2, 0. And then we have another one at 1, 2, 3, 4, 0. Okay, does that give us enough information to graph? No. If we had the vertex, something down here and point, then we could go ahead and do that. But we don't have that, so what do you need? We need the vertex. Okay, so if you think about how to find that vertex, we know that parabolas are symmetric. What about them is that they're easily, you can fold it. If you think about symmetry, you fold on top, and they're exactly the same on one side to the other. Well, that folding line for us is the axis of symmetry. Well, the axis of symmetry cuts this thing in half. So if we were to find the half of the distance between the x-intercepts, so if we find half, so half of the distance between the x-intercepts. Okay, so half the distance between the x-intercepts. Let's just stop there. Okay, so if we think about halfway between here, well, how do I find that? So if I go from here, 1, 2, 3, 4, 5, 6. So the distance between these 2 points is 6. So between these 2 points, the distance is 6. Okay, so if I think of the distance as 6 and I get half of that, and the halfway point between those 2 points is the axis of symmetry. So if you can find the half the distance between the x-intercepts, okay, you can find the axis of symmetry. So remember, so what we're going to do is we're going to take, let's say helps find axis of symmetry. Okay, so we have 6, so we're going to take half of 6, which is our distance, and we get 3. Now, that doesn't mean axis symmetry is x equals 3. It's the distance. So if I go, it's half the distance. So if I go halfway between these 2 points, 1, 2, 3, I wind up here. Same thing going the other direction. 1, 2, 3, I wind up there. Well, where do I wind up at? This line right here. Your AOS. Okay? That just helps you find it. helps to find it. So the axis of symmetry for us is, remember it's a line, x equals, well, that's 1. Okay, x equals 1. So now I only have part of the vertex. I need the other part. So my vertex so far is 1. Well, how do I find the other part? Remember, of the vertex. So remember, if you substitute the x value back into the equation, the original equation, you can find the y value. Okay, so now we'll substitute 1 back into the function. So remember the vertex is, we did negative b over 2a. It's an f of negative b over 2a. Well, our negative b over 2a is 1. So we want to substitute the 1 in there. So I'm going to have f of 1 equals, in place of my x value, I'll put a 1. So I have 1 plus 2 times a 1 minus 4 from the original equation. So that gives me a 3 times a negative 3, which equals negative 9. So f of 1. Okay, so that's just the other part of my vertex. And there's my vertex. Now I can plot my vertex. My vertex is always on the axis of symmetry. So let's plot our vertex. And again, it should be on negative, it's going to be 1, negative 9, which is down here. There's my vertex. Here's my other 2 points, and now I can graph them. So let's try the second example based on what we've done. The first things we want are the zeros. So again, we're going to set each of these equal to 0. So I get 2x plus 1 equals 0, and 2x minus 1 equals 0. 2x equals a negative 1. X equals negative 1/2. Here, 2x equals a positive 1, and x equals a positive 1/2. They are points, so please write them as points. We have 1/2 0, and we have a negative 1/2 0. Oops, I wrote that totally wrong. We have 1/2 0 and a negative 1/2, 0. All right, axis symmetry. We'll plot those points first. So we're going to plot them on this graph. I'm going to go halfway between negative 1 and halfway between 0 and 1. So halfway between 0 and negative 1 is right here, and halfway between 0 and 1 is here. So hopefully you see by looking at the axis of symmetry is 0, because one thing nice about this is the graph is just correct, so it's halfway between. But think about it this way. Between the whole distance, the distance here is 1, okay? And we said earlier that half of the distance of 1 helps us with our finding our axis of symmetry. So distance, if I take half of that, half of 1 is just 1/2. So halfway between those two is the axis, or x equals 0. So here's your axis of symmetry. So our axis of symmetry is just 0. Now to find the vertex, we have 0, comma, and in place of x, we're going to put f of 0. In place of x, we're going to put a 0, so I'm going to write f of 0 equals 2 times 0 plus 1, 2 times 0 minus 1. So this is 1 times a negative 1, which is just negative 1. So f of 0 equals negative 1. So this is a negative 1 here. So my vertex is this. So again, vertex always is on the axis of symmetry. So if I plot 0, negative 1, I'm right here. very, very tiny graph here because it comes down, hits here, and comes through here. Okay, in class on this next part, it was a critical thinking part. This is critical thinking portion, but you were working with a group. So what I'm gonna do is I'm gonna just go through it and make sure you understand why each is true or false. So use the graph of f of x equals ax squared, excuse me, ax squared plus bx plus c. Decide if each of the following is true or false. Remember, this is standard form. Okay, so we want to know if the axis of symmetry is 2. Well, we talked about if x equals 2. We talked about earlier, if you find the distance between these 2 points, okay, and then you take half of that distance and then move from each part that distance from each point to get to the middle or the halfway point, you should be able to see if that's the axis of symmetry. Well, the distance between -2 and 6 is just 8, okay? So distance is 8. So if I want to know if the axis of symmetry is 2, so half of 8 gives me 4. So from here to here, I go 4. And from here to here, I go 4. And the middle in between is my solution. So 6 minus 4 is 2. If I take -2, add 4, I wind up here at x equals 2. So this is true. The axis of symmetry is x equals 2. So again, I took half the distance, and then I count 4 both ways to get to the middle. So now I know the axis of symmetry is true. So to find the vertex, they want to know, is this true? So what do? I have this as true, that's right. So this tells me right here, is to substitute 2 for x and solve for y. Well, that's true. That's what you do. And that's just by definition. So this actually is just by definition itself. So I'm going to erase this so we kind of get the idea. So we know that the axis of symmetry was 2. We see it here going into here, okay? And we know that we take the 2, substitute back into the function, and then we find it. So we know that by definition, it's true. Okay? All right, next part. C, a less than 0. Whenever you see something's less than 0, that is a negative number. Same thing here, C is less than 0, negative number. So now we'll look at A. C, is A greater than 0? Well, A tells us what? And then it opens up and all that part. So if it opens up, then A is positive, okay? So what you want to do, so that means therefore this is false. So if A is positive, but they're asking you is A less than 0, true or false, that's false. A is positive, so it has to be greater than 0. So what you want to say, does it open up? Ask yourself, open up or down? So since A is positive, so it opens up because A is positive. Maybe I don't like that, it's positive. Positive A. So therefore, okay, therefore, A has to be greater than 0. Okay, so that's false. The next one, if you can see around all of my mess here, is C greater than 0. Excuse me, less than 0. So that means C is a negative number. Well, what is C? C is the y-intercept. So I'm going to ask this question down here. Is y-intercept negative? of a negative number? The answer is yes. Okay. So therefore, this has to be true. But look at the graph. Here's C. That's C. Okay. That's below in the negative area numbers, so therefore it is true. Okay, letter E. All right, let's look at what we have. We have f of 1 equals f of 3. Okay, so remember, even if you look up here at this f of x, what's inside that parentheses and x? So this is telling you, or asking you, I should say, but it's stating that f of 1 equals f of 3. Well, that means that this is x equals 1, and this is x equals 3. And what you're looking for, your point, remember, f of 1 is the y value, so I have 1, comma, f of 1 is this point. And here we have we have parentheses 3 and f of 3. So these are 2 points. Okay, so these 2 points here, we're going to see if they're the same, if these points are going to be equal, that means according to our definition, they must be equal distance from the axis of symmetry. So these points, what you see, are on the graph. They're somewhere down here, on our graph. Okay, so what we want to do is we want to see where is that to. So I'm going to get rid of these 2 things here. I'll get rid of all this. And I'll get rid of all that. Okay, so if I want to graph these, I know that right here, x is 1 and x is 3. I know that's right there because this is 2, right? That's 2. So that means that point lands somewhere here, and this point is somewhere on here. The question is, are they equal? So I want to say, so if this is true, what I mean statement here, if this is true, then we can even look at these points are symmetric to the axis of symmetry. Okay, so are x equal 1 and x equals 3 same distance from 2? From 2, which is your axis of symmetry? And the answer is a resounding yes. You can see right here. This is the same distance from 1 to 2 and 3 to 2. So this has to be true. Okay, next page. Write the equations of the following problems. And this should be not in standard form, but vertex form. So if you could change that to vertex form, because it doesn't make sense. You can't find it just by looking at what you have. Okay, so what we're going to do is we're going to look at the graph. Okay, for vertex form, let's write that down so remember what it is. So it's y equals a times x minus h, quantity squared plus k. So we need the following. We need the a, we need the h, and we need the k. So by looking at the graph, we can see our vertex. Remember, vertex is your h and your k. Okay, so if we look at the vertex, it's here, so it's -3, -4, and then now we've got to find the axis of symmetry. So we have the vertex, and now we've got to find A. Remember, we did these before. You would graph, you'd move over and plot, and then you were always out 1, and then when you hit the graph or go up or down, whatever which direction I told you, you know the next point, that would be your A. So we here go out 1 and up 1, so our A is a 1. And it's positive because we went up 1, but also look at the graph. The graph is up, so this opens up. So we have a positive number. All right, so when I write my equation, I get y equals 1x minus a -3 quantity squared plus a negative 4. I really wrote it this way so that you can see where we put things, but then we'll just clean this up. Maybe write this first. I kind of made it messy. So again, we're going to do y equals, the 1 goes away, it's understood. Okay, the minus and negative becomes a plus 3, and then plus and minus will be a minus 4. There's your vertex form. Also, what's helpful, by looking at just their equation, I went over 3 and down 4. I went to the left 3, and that's what happened. I went down 3. I went left 3 and down 4. All right, graph number 2. So here's our vertex. We see that our vertex is at there, which is negative 1, 0. We see that A is a negative 1 because when we go out 1 and we go down to this point here, that makes it a negative 1. Right equation, y equals negative 1. We don't put the 1 there. And we have x plus 1, quantity squared, and we have a positive 0. But again, we don't use that. So our final equation cleaned up is negative 1, x plus 1, quantity squared. Okay, number 3. Again, find the vertex and A. So the vertex here is we're going to go over to negative 4 and up to positive 4. So vertex is negative 4, 4. A is equal to, I don't need the axis symmetry, I was got to say that. But A, one thing about when we do problems, majority of the problems are going to be like 1/4, 1/2, 3/4, not really using thirds a lot. So this is actually a fourth. So we went over 1 and down a fourth. So this opens down, so it's 1/4. Okay, so down. That's because we're seeing the graph. We know it's got to be negative. But again, we went over 1 and down to that point on my graph, which is at 1/4. So write in our equation, y equals negative 1/4 x plus 4 quantity squared plus 4. Okay, now we're going to write the following equations in standard form. Standard form, again, remember, is y equals ax squared plus bx plus c. So we're going to write in standard form. So the first thing we need to do is to get rid of the square. So remember, when you see that square, that means we're writing this twice. Okay, so we're going to FOIL this and then combine like terms. I'm going to FOIL using the box method. X times x squared, 3 times 3 is, x times 3 is 3x, 3x, and then 3 times 3 is 9. So I look at these two, and I get 6x. So I want to use this, and that. So I'm going to write equals x squared plus 6x plus 9 minus 9. Clean this up. 9 minus 9 by combining like terms. So 9 minus 9 is 0. So our final equation is this. Number 2. Same thing. And factor that out. So we get negative 3 x minus 1 plus 2. Number 3 is I can't distribute the negative 3 first. I have to take care of those squares like that. So you can multiply negative 3 into the first binomial, but if you mess yourself up, I highly recommend just multiplying by these two together. So again, I'm going to use the box method. X squared minus x plus 1. That So I want this, this, and that one. So y equals -3 times x squared minus 2x plus 1 plus 2. Now distribute your 3. So we got y equals -3x squared plus 6x minus 3 plus 2. And so now combine like terms, y equals -3x squared plus 6x, -3 plus 2 is a -1. And that's your solution. Again, pay attention to that. This a is the same as this a.